Okay, so for today's lesson, we're going to look at finding unknown factors, and then we are going to look at using proportions to solve ratio word problems. And in doing this lesson today, let me get my marker that I want. That'll work. In doing today's lesson, guys, it starts off with this idea we're trying to solve for a variable. We're trying to solve for x or n or whatever the variable is. You remember a variable is something that we don't have a number assigned to it yet. Okay, so we know that that a variable, write this down, a variable means it's something we don't know the value of, and the value can be different for different problems. That's a variable, right? So I can say 2x equals, or let me do this over. I can say 2 plus x equals 5, and what value does x have? Mason? X has a value of 3. Well, when I'm saying here it can be different for different problems, I can then turn around and say 3 plus x equals 9. What's the value of x now? Anybody? 6, right? So see how it's the same variable, but it has a different value. It depends on the problem. Now, the number 2 here, the number 3, they're called constants. They're never going to change. They're constant, right? That's the constant. 2 in this problem is the same as if I were adding 2 to this problem. It has the same value. The number 2, it has a value of 2. We already know what the value is. It's a constant number. It doesn't change, okay? If I say 3 plus what equals 5, and I know that my variable here is going to be whatever this is. This is the variable. It's going to be 2, but I have a 3 here. The 3 makes this 2 equal to 5. If I put down a 4 plus x equals 5, I know my answer is going to be 1. But if I had a 3 here, if I put a 3 here instead, and this were a 3, and I change my variable to 1, this is constant. I can't say, well, this must be a 4. If there's a number, a value assigned to this, whatever it is, that's the value. A constant, the value never changes. It's always whatever number it is, that's the constant value of that number. It cannot change. And that's all we're talking about here when we're talking about finding unknown factors. Because when we're trying to find unknown factors, we're trying to find a variable. So we are faced in this quest, we are faced with a problem like this, guys. We have a problem where we have 5n equals 21. Okay, and we're trying to solve for n. You agree with me? We're trying to solve for n, trying to find the value of n. Okay, and you should hopefully by now you know, because we've done this several times, that to find the value of n, you have to get n by itself, right? Does that sound familiar? You have to get the n by itself. So we have this 5 hanging around with the n right now. We have to get rid of the 5. So the way we do that, and remember we have an equal sign here. So what we're saying is whatever is on this side has to be equal to whatever is on this side. So if we're talking about keeping things equal, whatever we do to this side over here, we have to do to the side over here, the right side, okay? So how do I get the n by itself over here, Mason? I divide it by 5, and we said if I do something to one side, I have to do it to the other, right? So I got to divide both sides by 5. This cancels out my 5's, obviously, right? And that leaves me with what over here? N. You agree? It leaves me with n equals 21 over 5. But we're going to put this into a mixed number because we don't like improper fractions, okay? So our next step then would be to say n equals to 21 divided by 5. And we know that 5 goes into our decimals right here, so we're going to put our decimal right here. And we know 5 goes into 21 4 times. 5 times 4 is 20. 1 left over, right? We got to bring a 0 down. And then 5 goes into 10 twice. Notice it goes on the other side of the decimal now. 5 times 2 is 10. We zero out, so we're done. So our answer is 4.2. 4.2. Or we could have said we had a remainder of 1. We could have said 4 with the remainder of 1 over the denominator of 1/5, right? So we could have had a fraction 4 1/5, or we could have the decimal 4.2, and that would be the correct answer. Does that make sense? So that means ultimately, if we take this n here and we get rid of it, and we say now we're saying 5 times 4.2 equals 21, would that be a true statement? That's the question. Because we're saying if we take 4.2 times 5, it should be 21. Well, let's see. What's 5 times 2? It's 10. And then 5 times 4 is 20. Plus 1 is 21. We have how many decimal places do we have to move it? Tucker? 1. So we're right here, so we move it 1, and we're at 21. What do you know? It worked out. That makes sense? Good. Good. So now we're going to look at another problem. We're going to take 0.6 m equals 0.048. Now, Skylar, what's the first thing I want to do here? What am I trying to do? Trying to get m alone, yep. Okay, so that's good. So I try to get m alone. Tucker, how would I go about doing that? Yeah. Do what? It's not 6. Look real close. It's not 6. 0.6. And Wyatt, do I have to divide both sides or just the one side by 0.6? Okay. So, Peter, when I divide both sides by 0.6, what happens? This is my left side. Here's my equal sign. Here's my right side. When I divide both sides by 0.6, Peter, what happens on the left side? Okay. And then over here, I'm going to have m equals 0.048 divided by 0.6. Would you agree? Now, guys, does anybody remember what I have to do? Because now, basically, to find the value of m, I have to take 0.048, and I want to divide into it 0.6, right? Does anybody remember what I have to do with the decimals before I start dividing? Glenn? I do. So I have to move. So basically, what Glenn is saying is I have to take this decimal and I have to move it over to here, right, Glenn? And if I do that, one spot, I have to do this over here one spot too, correct? So I'm going to move this over to here, right? Let me get my eraser and erase where we had them because we don't want them there anymore. Okay, and now, so here's my problem. So now I can rewrite this as to m equals 6 divided by 0.48. I don't really need those zeros, do I? They're kind of just there in the way. I bring my decimal up. Okay, now I can do my math. How many times does 6 go into 4? 0 times, right? And then how many times does, so obviously 6 times 0 is 0. I bring down my 4. Now I have to bring down my 8. How many times does 6 go into 48? 8 times. 8 times 6 is 48. I've zeroed out, so there's nothing left to do. So what's my answer? Yes, what's my answer? Tell me. 0.08. 0.08 is my answer. So m has a value of 0.08. So this is like saying if I take 0.6 times 0.08, I'm going to get 0.48. Does everybody understand that? Not too bad, right? Are we okay? Are there any problems with this? Okay. Let's look at one more problem. We're going to take 45. Let me get a different color here. 45 is equal to 4x. Peter, what's the first thing I do? Yes, I have to divide both sides by 4 so I can get x by itself. And when I do that, of course, the 4's cancel out. It leaves me with x equals 45 over 4. Okay, so I know now I'm going to take 45 divided by 4 equals x. Okay, and then I have 45, so my decimal's right here, right? So I'm going to bring it right up here. How many times does 4 go into 4? One time. And 4 times 4 is 4, so it's 0. I got to bring down my 5. How many times does 4 go into 5? Once. 4 times, I'm going to, hang on, I'm going to lose this here. 4 times 1 is 4. I have 1 left over. I have to bring down a 0. 4 goes into 10 how many times? Twice. 4 times 2 is 8. Gives me 2 left over. I have to bring down a 0. 4 goes into 20 how many times? 5. 4. So 5 times 4 is 20. My balance out. So I wind up with x having a value of 11.25. Huh? Or 11 1/4. That's right. Because I could say that 11 times 4 is 44. It leaves me 1 left over, so I could bring my 1 up here and have 1 over 4, right? Absolutely. Either way is fine. Okay? Everybody understand that? It's not so bad, is it? All right. Take out a piece of paper. This should have been, no, it wouldn't have been in your practice set actually because you didn't do this. Go ahead and try to do practice set A. I'm going to write it down for you up here if you want to see it. It's 6W equals 21. Try to do that one. Huh? Yeah. What? This is 87. It's 87. Mason? I'm not sure that we did in this class. There seems to be a bit of confusion about whether or not we started 87 or not. We did do this? I thought we did. I thought we did. Well, it's a good review. Did everybody do the homework for it? Then it has to have been done. Then we had to have done it in class. If you had the homework done, then we had to have covered it. But it's okay to review it. It's okay to review it. It's no big deal. Huh? Yeah. Okay, guys, so are we done with this problem? Practice set A yet? I'm going to pause this tape here. Okay, guys, so here's what we should have done. We should have divided both sides by 6. Cancels the 6's out. We're left with W equals 21 divided by 6, basically. And W is going to equal 6 goes into 21. My decimal goes right here by this. 6 goes into 21 3 times. 6 times 3 is 18. Gives me 3 left over. I got to bring down a 0. 6 goes into 30 5 times, so I have 3.5 because 6 times 5 is 30. It zeroes out, so we're done with the math. And I'm left with my answer of 3.5, 3.5. Okay. Now, if I didn't want to make that a decimal, I could have just said I had 3 left over, so I could have made it 3.3 left over my denominator. And then, of course, 3/6 can be reduced down to 3 1/2. So 3 1/2 or 3.5 is the answer. Did everybody get that? Good. Good job. Good job. Good job. Okay. Well, let's move on to, if you didn't do the practice set over the weekend, go ahead and do the practice set tonight. You don't have to do the written practice from this lesson if you didn't do it, but certainly the practice set you want to do. And now we're going to go ahead and look at lesson 88. Tucker? Okay, guys, so we're going to start lesson 88. We still have 30 minutes of class left, so we got plenty of time. And because 87 was a bit of a review, because I do think we covered most of that. Maybe we didn't finish it, but pretty sure we started it. So anyway, lesson 88, using proportions to solve word problems. So for this lesson, from these type of questions, guys, you have to make sure that you read the questions carefully. Skylar, stop looking at Glenn. He doesn't have the answers. I do. Okay, look like you're looking at Glenn. Just put the book in front of you then, because I thought your eyeballs were on him, not on your book. Listen, you guys have to pay attention to what I'm telling you, because I'm telling you that if you're not focused on what I'm saying, you're going to forget about this. You'll understand it today, but tonight when you go home, when you do your homework, you're not going to remember what I said. So it's important that you listen carefully, you watch the board, Listen to what I'm saying. And then when we do these questions, I want you to do them exactly like I'm showing you. So when you get home tonight, instead of trying to recall and do mental math or try to remember, what did Dr. Krawcheck say? I don't remember what we do with this. You'll have a good set of notes to look at, to review everything, so it'll make sense, and it'll help you do well on the test and even on tomorrow's quiz, because this will be on the quiz tomorrow. Okay? So if you have any questions, make sure that you get those questions answered before you leave today. If we don't have time in class, come see me at lunch for a few minutes. I'm here from 3:15 till 3:30. Come see me after school for a few minutes. Whatever you have to do. Call me tonight. If I'm on by my phone, I'll answer it. I'll help you through a problem on the phone if I have to. Just make sure you have your parents' permission, of course, and do whatever you have to do. So here we go. We're going to look at this idea of ratio problems. So, guys, whenever we have these word problems and we're comparing something to something else, when they tell us that something has this and then something else like that has this, what is this going to have? Anything like that, we got to be thinking about how do we solve this kind of a problem. Now, when a problem tells us that it's a ratio problem like this first example does, instantly we know the way to figure out the answers to a lot of these problems is to make a box. And your box, you want it to look something like this. You're going to make a box on your paper, and you're going to have a heading line for that box. Then you're going to have two sections for the answers for the numbers in your box. And we're going to divide this box into two. Okay? On one side of the box, the left side, it's going to be a ratio of something. And then over here on the right side, it's going to be the actual count. The actual count or the number or something like that. Okay? That's how these are all going to look. Now let's look at our sample problem, our example problem 1, and see if we can make some sense out of this problem. It says, and then we're talking about proportions here now, right? The ratio of salamanders. So I see the word ratio in my problem. I instantly know I have to have a ratio box. So the ratio of salamanders, I'm going to call them salamanders, sal. The ratio of salamanders to frogs. Okay? Notice I set up in my box just the way that the question read. It said the ratio of salamanders to frogs. So I wrote down salamanders to frogs. Y'all see that? I didn't write frogs first. It mentioned salamanders first, so that's what I'm writing down first. The ratio of salamanders to frogs was 5 to 7. It said ratio, right? The ratio was 5 to 7. There's my ratio box, 5 to 7. The ratio of salamanders to frogs was 5 to 7. If there were 20 salamanders, there's my actual count, 20 salamanders, the question is how many frogs were there? Okay? That's what we don't know. Now remember, from the lesson we just did, we had problems like this. Now I'm going to put it in a different color. One of the problems we had was 5n equals 21. We just did that problem a minute ago. Do you remember that? Okay. Well, watch what's going to happen in today's lesson. So now we have to solve for x. Okay? What you have to realize is that when we have these ratio boxes, we have a left side and we have a right side. And in between, we have an equal sign. Okay? Because what we're saying is, we're saying that the information on the left side of this box is equal to the information on the right side of the box. Okay, so we want to take the information outside of these boxes and put it into a mathematical equation so we can solve for x. All the work is already done for us, guys. All we're doing now is we're simply taking the information out of the box, putting it outside the box so we can solve for x. So we have these fractions. We have a ratio of 5 to 7, 5 to 7, and that's the left side, right? You see where it's the left side? And then we have our equal sign, and we're saying 5/7 is equal to 20 over x. Do you see that? You see how I'm doing that? So we put down 5/7 is equal to 20 over x. Okay? That's where we're at so far. Now, when we have, does everybody see how I took this information out of the box and put it outside the box? Everybody see that? That would be step 1. Okay? Step 2, what do you think I have to do? Skylar? I do. I have to cross multiply. Very good. So I cross multiply 5 times x, and I get 5x. I have 5x, and then I have 7 times 20, which is 140. Okay? Now, does this look like anything else on this page? Does this here look like anything else on this page? What does it look like, Tucker? It looks like the problem we just did, right? So now we're done. Now we just used last week's lesson to solve for x. And how do we solve for x, guys, when we have 5x equals 140? How do we solve for that, Peter? We're at step 2. How do we do step 2? Divide both sides by what? By 5. Divide by both sides by 5. I cancel out my 5's. And my third step is I get x equals 140 over 5. Okay, so my fourth step over here is going to be 140 divided by 5. And I do my math. And by the way, that's x equals, by the way. So my decimal's right here. So I want to put it up there in my answer so I don't forget. How many times does 5 go into 14? 2 times. 5 times 2 is 10. Have a 4 left over. I bring down my 0. How many times does 5 go into 40? 8. 8 times 5 is 40. I get a 0, so I'm done. So what is my x value? So my last step, x is equal to what? 28. So I can come over here and I can write down 28 as my answer. Does that make sense? Well, let's see. The ratio of salamanders to frogs is 5 to 7. There's more frogs, and I do have more frogs in my actual count, so it makes sense. It is possible. Now, that's all we have to do. Now, if I wanted to check my answer, I can put the value of x into my problem, because my problem was 5x equals 140. So if I take 5 and put in the value of x, which is 28, equals 140, if I multiply 28 times 5, what do you think I get? Tucker? Absolutely, I'm going to get 140. So 140 equals 140. Now, let me go back to what Ben said, because I kind of cut him off being a little short, but Ben was absolutely right. If I wanted to, I can take these numbers over here. Let me get a different color marker. Try this color. I can take the 5 and the 20, and I can simplify that, or I can reduce it down, right? I can divide both of these by 5, so this would become a 1. Basically, I can make that a 1. This is going to become a 4. And look how much easier it is now. Now I take 1 times x, and I get x, and 7 times 4 is 28. So you can reduce it down left to right when you have equal signs, if that doesn't confuse you. The reason why I'm kind of concerned about that is some of you mistakenly, what I'm afraid of is some of you are mistakenly going to cross multiply the 7 or try to reduce the 7 and the 20, and you can't do that. And if it was a number where you could, like if that was a 4, I wouldn't want you making that mistake. So remember, if you're going to reduce, when you have equal signs, the equal sign is telling you what direction you can reduce in. If you put little arrows on the end, you can reduce left or right, but you cannot cross reduce. You cannot do that. Cannot cross reduce. Okay, does that make sense? Everybody grab that? All right, Mason, what's your question? Yeah, we don't want to do that. We're not trying to do that. That was a lesson some time ago. This is a new lesson. This lesson is teaching you how to use proportions to solve word problems, because next year you're going to be doing a lot of this. Okay? Huh? No, we didn't do lesson 88. We did something similar to this, but there's subtle changes, and they're trying to do baby steps with you. Now, listen, let's look at example 2. This one's a little bit different, but once again, I'm going to have my box. Okay, guys, we have 3 sacks of concrete. That'll make 12 square feet of sidewalk. Predict how many sacks of concrete are needed to make 40 square feet of sidewalk. Without looking at your book and your book telling you how to do it, somebody try to walk me through this and tell me how I would set this up without looking at your book. Okay, Wyatt. Right here? Over here? Sacks of what? Don't look at the book. I don't want you looking at the book. I know if you read it, you can see the answers. I'm not questioning your ability to read. I'm concerned about your ability to do math. Okay? Sacks and square feet. Do you know why we put sacks on top and square feet on the bottom? Because it said that? Yep, 3 sacks of concrete make 12 square feet. So what's going to go in this box right here? What am I putting in? Ratio. Okay, and then Tucker, what goes in this box over here? What word goes over here? Skylar. Actual number or actual count, right? All right. All right, so I'm going to start looking at my numbers and my word problems. I have 3 sacks, I have 12 square feet, and I have 40 square feet. Where do I put all that mess? Peter? Where do I put the 3? It says I have 3 sacks of concrete. Where does that go? Under the ratio. Good. Are you looking at the book for that, or do you know it? Guys, I'll make you close your book if I see you looking at the book. Any of you can read and see where the numbers go. I'm not interested in your ability to read. I'm interested in your ability to think critically and know where these numbers go. The answers are in your book, but I don't want you looking at the book and just reading me the answers. I can do that myself. Okay? All right, Skylar. We got 3 sacks of concrete, makes 12 square feet of sidewalk. Where's the 12 going to go? Square feet over here under actual count? Goes under the ratio because we know that 3 sacks make 12 square feet, right? And then it tells us that we want to make that. It tells us that to make 40 square feet, how many sacks of concrete do we need? So what's my x variable here? What's the x going to be, Glenn? Right, because that's telling me how many square feet I have, right? And so what I know about this problem is if I have 3 sacks of concrete that can make 12 square feet of concrete, how many sacks do I need to make 40 square feet of concrete? Do y'all see that? So far, so good, right? So what do you think, Peter, would be my very first step in solving this problem? What am I doing? Okay. Glenn? Okay, like that. Okay, what goes in between them? Okay, great. Step number 2. Tucker? What? No, I don't divide x into 40. What do I do next? Skylar? What do I do, Tucker? How do I do that? Do what? X and 40 are already next to each other. Then you would be incorrect. Why? What do I do? Guys, where y'all at on this? Mason. Thank you. Come on, guys. Yes, we have to cross multiply. The next step is to cross multiply. That's why you got to write all this stuff down. So you're relying on your memory. I would love to see your notebook right now to see if you wrote down the steps. Did any of you guys write down the steps for the first problem? So you're relying on exactly what I told you not to do. I told you before we started, don't rely on your memory. Write everything down so you have a reference. And so we're doing these. You're taking absolutely no notes in class. You're going to rely on your memory. You're going to rely on your memory. You still aren't taking good notes, Peter. You're relying on your memory, and your memory is not going to do anything for you tonight. You can't even use your memory for what we learned 3 minutes ago. How are you going to remember this in 8 hours when you're doing your homework? You're not. And then you're going to come in tomorrow and take a quiz on this and have no clue how to do it and get them wrong. Why? Get out your pencils and copy down what I'm doing. Guys, I know how to do this. I'm not doing this for me. I'm doing this for you. Write it down. Write down every single step. If it wasn't important, why would I write it? I wouldn't. I'm writing it down to show you how to solve this problem. You are not geniuses yet. I think you can be, but you're not yet. Otherwise, you'd be in college. You're here in 6th grade math with me, right? These are concepts that for you might be a little confusing. You have to write them down so you can study them. You have to look at this and say, okay, I remember step 1. That's why I'm numbering it for you, so you can see the steps. Okay, I might even put in between step 1 and 2 CM for cross multiply, so I remember. Listen, whatever you got to do, guys, just write it down so when you're home tonight and I'm not there with you, and your parents are making dinner and your dad's not home from work yet, or your mom's not home from work yet, and you're doing your homework, you can look at your notes in class and figure this stuff out, so it makes sense. If you don't take good notes, you're going to be lost tonight, and then you're going to be lost tomorrow on the quiz. Okay? So yes, Mason's right. We cross multiply, and we multiply 3 times 40, and we get 120, and we multiply 12 times x, and we get 12x. Now, what is our third step, Skylar? Absolutely. We want to get x alone, so we're going to divide 12x by 12, right? Absolutely. Good job. So that's my next step, right? And then what's going to happen here is these 12s cancel out, don't they, right? And that leaves me with what, Tucker? That leaves me x equals 120 over 12. So my step 5 over here, I'm just going to rewrite this down. X equals 120 divided by 12, right? Isn't 120 divided by 12 the same thing as 120 over 12? It is, right? So I'm just writing it down in a way that I can do the math. So my 6th step is going to be to do the math that I have here. And when I take 120 and divide it by 12, what's my answer? 10, right? Everybody knows that 12 times 10 is 120, correct? So x equals 10. So I come back up here to my problem, and I can say that the number is going to be 10. X is equal to 10. And let's see if that's true. Remember, we have 3 12ths equals 40. Oh, I'm sorry, equals x over 40. And we said that 12x equals 120. Remember that? It's over here somewhere, right there. Well, if I take 12 and put the value of x in there, which is 10, equals 120, is that a true statement? What's 12 times 10? 120 equals 120. So that proves that we're right. Make sense, guys? Okay, here's what I want you to do. I want you to look at the practice set A on page 458 and try to do it. I'm going to erase all this. Much better, Peter. Very good. Proud of you, kid. Take good notes, guys. Everything that I wrote down, use it as a reference so you'll be able to go back and figure it out. Good. Very nice. Yeah, that's very helpful for you guys. It's really important to do that. And that's true for you ladies that are listening too. We didn't do this in your class today on the pad, but we recorded it in the boys' class, so you'd have it tonight. Okay, there we go. I don't know why that was weird. All right, guys, so we have the ratio of DVDs. Here's the problem. I wrote it up there for you. It's kind of hard to read. The ratio of DVDs to CDs was 5 to 4. If there were 60 CDs, how many DVDs were there? Well, let me show you how I would set this up. I know it's a ratio problem, so I'm going to put my ratio over here. I'm going to put my actual count over here, ACT, right? And I know that the ratio of DVDs, that's listed first, I'm going to put that there, to CDs was 5 to 4. If there were 60 CDs, now here's where you can make a mistake. You can put the 60 up here thinking, well, that's first. I got to find the CDs and put the actual count next to the CDs. So I'm solving for X DVDs. How many DVDs were there? The DVDs goes right here. That's my X value. So I set this up. I take all the numbers out of the box, and I have 5/4, step 1. equals x over 60, right? Step 2 is I cross multiply and I get 300 equals 4x. Step 3 is I take and divide both sides by 4. So I'll have 300 over 4 equals 4x over 4. Step 4 is my 4's cancel out. That leaves me x equals 300 over 4. Step 5 is x equals 300 divided by 4. And now I just do my math. 7 goes into 37 times. That gives me 28. Gives me 2 left over. I got to bring down a 0. 4 goes into 25 times. 5 times 4 is 20. So I balance out, and my answer is 75. 75 is my answer. So I put up in here, nice big 75. And then, guys, what I can do is I can go back to step 2 of my problem. I can go back to step 2 of my problem right here. I can redo it. I can say, okay, 300 equals 4 times x, which was 75. And that should be an equality, right? The equal sign saying that it's an equality. The left side and right side should be the same. So 300 equals 75 times 4. What is 75 times 4? It's 300. So it does work. So the number was right. Everybody, who got that right? Everybody? Any questions about this lesson today? Okay, listen, I want you to do the practice set tonight. I want you to do the practice set from lesson 87. If you already didn't do it, most of you did. But do the practice set for tonight, and there's only 2 of them, A and B, and we just did A, and then do all of the written practice, 1 through 30 all, okay, and know that we will have a quiz tomorrow, okay? All right, guys. Hey, make sure you tell the girls this is on the blog tonight so they can review this, okay? And I'm going to try to have the answers to the homework on the blog as well.